And now may I call upon the Brennan Research Professor, Chemistry and Earth System Science, School of Physical Sciences, University of California, Dr. F. Sherwood Rowland.
Thank you, Mr. Chairman. I'm Sherwood Rowland, Professor of Chemistry and Earth System Science at the University of California, Irvine, where I have been for more than 40 years. I first testified to the U.S. Congress in December 1974 in connection with a study published that year with Professor Mario Molina on the depletion of stratospheric ozone by the chlorofluorocarbon gases, then used worldwide as refrigerants and aerosol propellants. The following year, these same gases were identified as being potent greenhouse gases, despite their very low concentrations in Earth's atmosphere. 3 years later, members of our research laboratory at the University of California, Irvine, began collecting ground-level atmospheric samples in widely distributed remote locations in both northern and southern hemispheres to monitor these rising global CFC concentrations. When we extended our studies beyond the CFCs, we quickly discovered that the concentrations of methane gas found in these samples after emission from rice paddies, swamps, coal mines, cows, and other sources were also increasing. Because of the greenhouse gas significance of both CFCs and methane, we have continued now for 28 years with financial support from NASA to monitor these gases in atmospheric samples collected quarterly from northern Alaska to southern New Zealand. The concentration of methane gas in the atmosphere has more than doubled since 1800, as shown by comparison with the concentrations found in air bubbles in glacial ice cores. This growth has made methane a significant contributor to added global greenhouse forcing over these 2 centuries, second only to gaseous carbon dioxide in quantitative importance up to the present. In our continuing analyses of atmospheric composition, we now have a record more than a decade long in both hemispheres of the concentrations of more than 100 gaseous molecules of either natural or industrial origin. In addition, with the support of the Department of Energy, we have applied the identical analytical techniques to the same set of atmospheric gases in more than 20 U.S. and many foreign cities, and to the U.S. Southwest as a region. These data are very pertinent to estimates of the contributions of tropospheric ozone, another greenhouse gas. All of these studies form a small part of the much larger scientific understanding of the greenhouse effect, global warming, and the accompanying concern about abrupt climate change. This background of participation in the atmospheric science community has meant interactions both within the science itself and in its interfaces with the various governmental organizations and the general public. Beginning in 1988, the global scientific understanding of these areas began to be organized internationally by the Intergovernmental Panel on Climate Change, or IPCC. The initial portion of the 4th IPCC report on the fundamental science of the planetary energy balances and how they affect the climate was reported in Paris last week. It was and is a very stark presentation of how the growing concentrations of the greenhouse gases and other ongoing atmospheric changes are already significantly affecting large portions of the Earth. For example, melting of ice in the polar north and prolonged severe drought in southeastern Australia. The outlook for the coming decades is for much further change, including rising sea level, hurricane intensity, etc. This IPCC report represents an outstanding effort on the part of the international scientific community and has the support of almost all of its members. Complete unanimity is never expected, nor is there any mechanism for establishing the competence and credibility of those claiming to speak as scientists, other than the seldom performed examination of his or her record of past successes and failures. The closer we come to widespread public interest from the general public, the harder it becomes to evaluate the merits of the scientific case in the mix of other opinion. The IPCC report represents the best effort of the scientific community to evaluate the problems of climate change, and it should be listened to us. Those of us who are based in universities are accustomed to presenting directly our findings and our opinions about the context of our results. In most of my experience, our colleagues in national laboratories have had almost as much freedom in their presentations. Describing one's work as one sees it is the bedrock of the scientific enterprise. However, in the last several years, my scientific conversations have run into far too many instances in which the reports of the significance of the work have been subsequently changed by others, often by persons with less or even no expertise in the subject at hand. Some of these conflicts have been gathered together with verified details by the Union of Concerned Scientists and by the Government Accountability Project and are presented here today. Working out the best approaches to mitigation or adaptation to future climatic change is critically dependent upon possession of the most accurate and pertinent knowledge. I will conclude by quoting the remarks of the late Senator John Tafey of Rhode Island at the closing of a hearing on the atmosphere which had just been held with the Senate Subcommittee on the Environment, which he chaired. If we were masters of the world, we would do something about carbon dioxide, but we are not. We can't tell the Soviets what to do or the Chinese, but it seems to me that is not an excuse for no action at all on the part of the United States. That is why I find fault with the view that if we take action, the Europeans may not. But that's not a call to inaction to me. We ought to do what we can and set an example. These were his comments to us in June of 1986, and unfortunately, they are just as applicable now as they were 21 years ago. Thank you.